Hey everyone, this is the 8.1 worksheet. So what we're going to do is build off of the idea of taking a circle, and then within that circle we always end up creating triangles. And so what we're going to do today is start to take away that circle and only be looking at triangles. Okay, so what we're going to do to start with is, by using the hypotenuse of the triangle below as the radius, I want you to construct a circle with its center at the vertex of the angle such that the radius is 5. So what we mean by that is you're going to take your compass and you're going to put the pin on point B, you're going to put the pencil on point A, and then go ahead and draw your circle. One thing I want to point out is, notice that this right here, we have the end of our triangle, but it does not connect to that circle. There's always just going to be a little bit of space there. So if you're freehanding that circle, make sure you leave that space. Okay, then next we are going to determine the sine of theta without determining the value of theta. So here we've got our sine function, and because we're looking at sine, that means we are looking at the vertical distance. Right, that's always the key thing I want you to remember. Okay, and so since we're looking at the vertical distance, that means that is going to be y equals r sine of theta. And then the y value in this case, so remember we're looking at this as our circle like we've done before. The vertical distance is 3 equals our radius is 5. And then we have sine of theta. To get sine of theta by itself, we divide both sides by 5. So we get 3/5 is equal to sine of theta. And then we can stop there because we're looking at sine of theta and not the theta, so we don't have to do the inverse. We will later, but not right now. All right, let's go ahead and do this one more time. So again, go ahead and take your compass, and I want you to construct a circle around that triangle. And here our radius is going to be 5.43 and our vertical distance is 1.92. So again, we're going to find our sine of theta. So we get y equals r sine of theta. Our y is 1.92. R is 5.43. And then to get sine of theta by itself, divide by 5.43. And that gives us our answer. Okay, and so again, we have our circle that we've seen before, and now we're just really building in that triangle within that circle. All right, let's go ahead and take a look at this one. So using the hypotenuse of the triangle, again, construct another circle so that the radius is 4. Okay, next it says find the length of segment BC, right? So that means we're going to go from point B to point C. This is not the radius of the circle. This is not going to be 4 because from B to the edge of our circle is going to be 4. So we want to make it very clear that the length from B to C is not our radius. Okay, so this is going to bring back some high school material. So since we're trying to find one side of our triangle, and notice we know the other two sides. We know the hypotenuse and we know one of the legs. That means we're going to use our Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. So A and C are always going to be the legs of our triangle. The C is always going to be the hypotenuse. The hypotenuse is always going to be opposite of this right angle. So I'm just highlighting the right angle here. The hypotenuse is always going to be opposite of that. Okay, so let's go ahead and plug in some of those values. So one of the legs is 2.4 squared plus, we're going to leave b as a variable, so we have b squared equals, and then our c again is that hypotenuse, which is going to be 4 squared. Okay, simplifying this, we get 5.76 plus b squared equals 16. And then because the 5.76 is added to b squared, we are going to undo that. So we are going to subtract 5.76. So we get b squared equals 10.24, and then don't forget we need to take the square root of both sides. So we get b is equal to 3.2. Technically, it should be plus or minus whenever we do this kind of operation, but because we're talking about length or a distance, that means it has to be the positive of that. So it's going to be a positive 3.2. All right, so now that we have our b value, we can then go ahead and finish our question. So this time we are looking for the cosine of theta. So cosine of theta is our horizontal distance. So we get x equals r cosine theta. X is 3.2 equals 4 cosine theta. And then divide both sides by 4. That gives us cosine of theta is equal to 3.2 divided by 4. Again, we are not determining our theta value, so we do not need to take the inverse. This is just us learning how to work with triangles. All right, so the triangle can be in any orientation. So notice here I'm not asking you to draw the circle because the goal is to start to take that circle away and to only think about triangles. So the triangle can be in any orientation, and I want you to find both the sine and the cosine. So here is our right angle, so that means that the 10.6 is going to be the hypotenuse. Okay, and then if this right here is going to be our angle, then this is the 6.6 is our vertical distance, and then the 8.3 is going to be the horizontal distance. Okay, and then we can find both the sine and the cosine. So we'll start with sine. So y equals r sine of theta. Y is 6.6 equals 10.6 sine of theta. And then divide both sides by 10.6. So that gives us our sine of theta. And then we're going to do the same thing with our cosine. So cosine is horizontal distance, so x equals r cosine theta. Horizontal distance is 8.3. And then plug in the r, and then divide by the r. And that gives us our cosine of theta. Okay, so the idea is again that we are taking away that circle and only looking at the triangle, but the same ideas apply, that one side is going to be a vertical distance, one side is going to be the horizontal distance. All right, we will continue this discussion in the next video.